So this new thing is called parametrics. It's the new chapter. And parametrics has an S on the end of it because parametrics, you don't see a parametric equation as in single. They're double equations. You always have a set of two. Let me help you understand what it does. First of all, let's say I had a normal equation. Let's just make sure you remember this. Instead of negative 4.9, I'm going to say negative 5 just because it will flow a lot easier. Do you remember this was, you started at 1 meter off the ground, and it was thrown into the air at 8 meters per second. And this is the gravitational constant part of it, which is technically the gravitational constant divided by 2, but ends up being negative 4.9. I have rounded to negative 5, so you don't have to get out a calculator to do all these calculations. And then that is your typical parabola. Why don't you make a quick sketch? You kind of know where it starts. You kind of know what shape it looks like. Just make a quick sketch of this. This is supposed to be in your wheelhouse at this point. When you're drifting, get back, write that down, sketch it. I'm glad a lot of people are putting a dot right here. That's where it starts. Very good. Just a sketch. Just a quick sketch. Would you agree that it generally goes up and comes back down again? There we go. That's generally what this looks like. Now remember, if we're graphing this, this is height and time down here. So if you give me a spot like right here, that might be at time 2 seconds. The height was at 43 meters. I don't know what it is. I'm just saying that's a spot, and that's time and height. That's all it is. Notice I don't know how far away the ball is from you. I only know the height. The ball could be traveling laterally, like away from you, or it could be just going straight up in the air. You can't tell. Now, how would a parametric be different than this? On a parametric, you could get more information. All this is height and time. What if we could get height, time, and distance away from you all into one graph? Seems really complicated, but it's really not that bad. Okay, I'm going to go through and make a new one. You can leave this one up as kind of just a review of parabolas. That kind of stuff can be on your final. Okay, but then this new thing is like it, but different. So now make another page, or slide down enough. This is going to have a y equals, there's just a subtle change right now. What did I do different? Yeah, you replaced the t in there. Well, that seems like we even did that sometimes. Well, then it would only be time and height, and you wouldn't have any more info than we had last time. So how is it different? Because then we have an x equals equation. Now we got more info than we ever had before. Because we now can tell at any given time what is the height and what is the x. Just to clarify, when this graph would be done, this would be still height. But the x here on this axis would be the distance away from you laterally. What's a nice short way to say that? How about horizontal distance? Instead of vertical distance, being height, right? Horizontal distance, like how far away it is this way. Okay, so this is going to be horizontal distance. Now, if I were to graph one of these things, could it still look like this? Yes, it could. But now, at this spot, I would know different things than I knew last time. I would know that its height is a certain thing. Like, let's say I say it's starting at 3 meters off the ground. Again, this would not be this one, otherwise it would be a 1. And its horizontal distance away from you is 0, as in it hasn't gone away from you. It's like still in your hand, but it's off the ground 3 feet. And then when we get this spot, it is not the time when it reached that height. Now it would be, let's say this is at, time is 1, and So wait a minute, horizontal distance is what this is. It's horizontal distance comma height. So let's say it's gotten to be, after a second, it's gotten to be 10 feet away from you, horizontally 10 feet away from you. It's like that way 10 feet. And its height might be, I don't know, 30. And this is in meters, so I guess that'd be 10 meters and 30 meters. Notice I don't have the time. Well, then how is this even any better? I only have two things. Because with parametrics, you also know the time. You'd start with a t, if I could draw a t, equals 0, and you label the time onto your graph. And then when it's time equals 1, and then when time equals 2, you see what I'm saying? You can label it, so now you have all three pieces of information, time and height and distance away from you. So this used to, on the old kind of graph, just be the time when the ball hit the ground. And now it's the moment that the ball is 0 feet off the ground, which is the moment the ball hit the ground. But at that moment, you can tell the distance away from you. See what I mean? If this distance then is 15 meters, well, then you know the ball landed 15 meters away from you. Get the difference? It's got more info. Okay. One last thing that parametrics always have, and this is important. Everything I'm telling you is important, but this is really important because people forget this, is it has a domain. And would you agree that this doesn't make any sense after time is, let's say, 2.5 or whenever the ball hit the ground? That doesn't make any sense after that. So I'm just going to make this a little nicer. You know this is a little unrealistic, but if I make the ball hit the ground exactly at time equals 2, and that's pretty nice, then it's gone from t equals 0 to t equals 2. So you write this. Time has to be between 0 and 2. That's called the domain. All right, I know these seem really scary, but honestly, this is easier than last unit. Way easier than last unit. You'll like these by the end. They won't be that hard at all. But you're going to learn a lot of it today. Today's one of those like long, intense, lots of things days, and you're going to walk out of here going, I'm not sure I get all this. You just have to get it by the end of the time when we actually take the test. Yes, sir. EL. That's a good question. How could we model it where the ball could come back towards us? That actually works in parametrics, and I'm excited to show you that. So, any more questions about this one, the way this one happened? Got more information than last time. We know how far away it is, and we know how high it is, and we know its time at any given moment. So you might be thinking, how do I actually get these points? Well, when we graph something, what's your best friend in graphic? XY chart. And I remember me saying that even things you really didn't know how to do it, you could still do it with an XY chart. You probably don't really know what to do on this, but we could do it with an XY chart. The only thing is we also have to include t. So I call it a TXY chart. Because you need the time and the x and the y at that time. So it's the TXY chart. So we'll make one of those in a moment, but here's what it would look like. TXY. It's just got 3 categories. And time is 0, times 1, times 2 is the typical numbers. You just pick time 0 and see what the x is and what the y is. At time 1, you see what the x is and what the y is. And then the last thing, I'll kind of give you the big overview here, is, do you agree this is just a parabola again? Isn't it just a parabola again? But it's a parabola that has very strict starting and ending spots. As in, it has to start here at t equals 0. The other parabola, I don't know if you remember, we'd sometimes extend it out, and we'd end up getting this negative time thing. It's like when you solved, you'd sometimes get 2 answers. One of them wasn't realistic. Well, parametrics have to start and stop somewhere. So this is a parabola, and you can rewrite this as a rectangular graph. You can write that as a normal graph. You're just going to lose the time element. So that's the last thing I have to teach you, is how to take a parametric equation, convert it over to a rectangular. But I'm going to start you off on an easier one than this, because this one's complicated because it's got a curve. All right, so somebody was just asking a second ago, like, what about can I use a paper airplane instead of a ball that comes back at you? Because I can't picture a ball wanting to all of a sudden in the air turn around and come back at you. Now, a paper airplane, though, would you agree a paper airplane could have a flight pattern that goes like that? You know what I'm saying? It could go away from you, go up, make a loop, and then go back down again. And then I've seen that before. That's a real thing. Well, parametrics can make that happen. You can write a system of parametrics that can do this. Now, a normal function can't do that because this isn't a function. Look at it. It's got a big place in it. It doesn't pass the vertical line test. But we can still do it with parametrics. All right, it's tough to say, here's my situation, now write me two equations that do that. That's hard to do. But with two equations, you can do this. One more thing about parametrics, they always have a direction. If the thing is going like this, and then starts going like that, and then starts going like that, that's how you denote the direction of the parametric. Your graphs in the past have never had a direction. I don't know if you've ever noticed that. You might have read from left to right, but when you have a parabola, who's to say that the parabola couldn't be written like that? Parabolas can go both directions, and they go forever in both directions. This is different. It only goes in one direction. It starts here, and it ends there, and I happen to do it that way because I read from left to right, but a parametric can absolutely start over here and end down there. Parametrics don't have that requirement of going both directions. They can go any way that they want to go. And then I'd have to know which direction they're going by looking at their little t labels. T equals 0 is over here. Oh, so then it started over here. And here's t equals 1. And t equals 2. And let's say this is where t equals 3 is. And let's say it touches here at t equals 4. There's no reason it has to go from left to right either. So last thought, they have a direction. Okay, so let's start on an easy one for you actually doing one. There's always an x equals equation, and there's always a y equals an equation, and they always have t in them. So let's give you a super simple one. T plus 1 and 2t. That reminds me of Tudita. Do you remember the Tudita? Raise your hand if you remember the Tudita. There's a lot of you that remember it. My girls back when they were little kids used to do the Tudita. Those were the cutest thing ever. Got them recorded. Anyway, it's one of those precious memories. So, y equals 2t, x equals t plus 1. Who remembers something that I said would always be in a parametric, but it isn't there yet? The domain, very good. And that is that t can't go forever. It's almost always going to go between 0 and, let's say, 2. Or 0 and 1, or 0 and 3. Can t be something else? Yes. Sometimes t is an angle, like in trig, you know, cosine of an angle. Yeah, I know, that's kind of hard to think about. So for right now, just stick to the whole t thing. T is time. But t can be an angle, like between 0 and 360. 0 to 2 pi, right? All right. Okay, so TXY chart. You want a good example of this. And I want to remind you, one of the things you can do to prepare for a test better, hint, hint, some of you, hint, hint, that didn't do so well on this test. I actually felt a little bit bad because I'm like, dang, why didn't they do so well? And then I looked at how many people didn't turn in their homework. I'm like, wow. And then I even drilled down and looked at some of the practice problems, and some people really just, okay, you said to do 4, so I'll do exactly 4, and I will find the easiest problems in the world and do those 4. Do you think that was great prep for a test? Probably not. Yeah. Okay, now some of you, don't get me wrong, I looked. Some of you were like, holy crap, you did a ton of practice, and then usually they did pretty well. So anyway, moral of the story, I'm not taking all the blame on myself for that last test not going so well for some people, because some people didn't do it at all, and some people did it and only like, okay, fine, I'll do 4 super easy things. Well, then don't expect your test to be amazing. All right, and I did practice almost everything on that test with you. There was only one on there that I felt slightly bad about, but we're supposed to stretch you. It's an honors class. So one problem that's slightly different than we've done before out of 9, that's not that bad. Okay, so anyway, and the other thing that makes me feel good about it is if everybody had done badly, then it's like I must not have taught them this stuff. But a lot of people still got A's, which means it was doable. They were all taught the same stuff. So anyway, if you did bad, just know we're going to do corrections and stuff tomorrow. We're going to have some time built into the class tomorrow to do corrections. And if you didn't do so hot, you don't have to do a retake. But if you got a C, it might be. I might put a little dent in the grade. You might want to consider redoing your C. You have a week from when I give them back. It's another reason if I delay another day, it gives you a little bit more time. Because once I give them back, then you have a week to take your retake by. All right, so moving back to this TXY chart, would you please turn your iPad my way so I can see that you are all set up. You're ready to graph this thing. I see you're ready. You're ready, ready, and comfortable. Ready. Pretty much everybody is ready. Okay, awesome, thank you. 2 people in the back I'm a little suspicious of because you never showed me. Aha, get ready. Okay. Oh, maybe you're just hiding it. Okay. All right, so I'm going to put in t equals 0, t equals 1, and t equals 2, and I'm going to find the x and y points for that. It's really pretty simple. And this is the part where you'll probably work best if you and your partner together put this thing all together, get me a nice graph, and then I'm going to show you how to change it over. I bet a lot of people are going to forget something on this graph, and I'm not going to say what, but we'll see if you get caught. All right, these 2 rows slide next to each other. These 2 rows slide next to each other, except could you move up a notch, and then you can work with him? That'd be great. These 2 rows slide next to each other. You 2 are going to work. So you guys are going to be a group of 3, unless you want to move to the back. And then would you move up here, and this can be a group of 3. Okay? Good. Easter egg! Sweet! I've had something else that I really wanted to get. Oh, the titanium shovel is already in effect. Awesome. One of the other things that's been good about this is I'm writing down the names. No, that's my phone. No. Although it'd really be fun to be able to put a really stupid looking wallpaper on there for him of me making a dumb face. All right, anyway. So you're going to put in 0 and 1 and 2. You put in 0, and some of you are like, where do I put it? There and there. And then figure out what the answers are. I'm going to pause for a second while you finish this little chart and graph it. The graph, ideally, if you get graph paper, if you put a little Post-it in, you can put Post-its in that have graph paper on them. Do you know that? You can. Option B, you import a whole other piece of paper into, stickies, I think they call them. They don't call them Post-its because that's trademarked by 3M. But, okay. So anyway, get this graph nicely and compare it with the kid next to you, or work with the kid next to you. Okay, just make sure you're on the right track. You should have got, when you stuck in 0, you should have got 1 and 0. When you stuck in 1, you should have got 2 and 4. You doing it right? Okay. When t equals 1, this would be 1, and this would be 1. I did it wrong. Sorry. 2 and 2. Oopsie. It's like, how could you get it wrong already? And it was me getting it wrong. Sorry. Okay, 2 and 2. There we go. And I was thinking squared, but it wasn't squared. And then I stick in 2, and hopefully you got 3 and 4. And then you graph them, and you got 0, 1, 2, 2. Wait a minute. Yeah, that's right. Oh, I graphing the wrong thing. Remember? That's the only part that gets graphed. It's easy to forget that, but I don't have 3 axes. Otherwise, if I had an x and a y and a z axis, I could actually do that. So that is 1, 0. You know what I was graphing? And you're going to do this too at some point, unless you're probably smart enough to not do this. I graphed 0, 1. See why that's not okay? We don't graph the t's. All right. So there. And then 2, 2. And then 3, 4. Okay. I really should have put graph paper up here. This should be more like that. There. And then it's a straight line. Should I just put arrows on it and make it go forever? No. Who remembered to put arrows on it at all? Ah, 2 groups. That's a really easy mistake to make. But if you just had this on the test, I'd have to cry a little bit and take off 5% because it has a direction. So you got to put the little thingy on there. Here's another way to lose 5%. Did you put t equals 0, t equals 1, and t equals, not negative 1, what the heck? T equals 1, and t equals 2. Oh, I can't draw. I might double crossing my t's. Anyway, there. I've labeled it, and I got a direction, and it starts in one spot, ends at another. I don't have arrows on both ends. Yay, I think I've pretty much got it. That is part of, that's a parametric. It's got more information than you've ever had before in one graph. I really ought to label my axes, but in this case, I never said what they were, like chickens and cows. I'll just label them with an X and a Y. Yes? If you put an arrow on the end, you're implying it goes forever. That's why, I know it kind of feels weird to put arrows in the middle of things, but don't put them on the end, because otherwise that implies I'm going to just keep going, but it doesn't. It stops there. So no arrow on the end. You can put it even a couple times in the middle if you want. Okay, then, what did I say we were going to have to do, but we haven't done yet? Domain is a thing, yes, but I don't have to show that on the graph. It's not the domain thing. Change it over. And yes, we're going to do a quadratic for our more complicated problem, but we have to change this over from parametric to what? Rectangular. Now, I'm going to do this by just looking at it. That's called by inspection. I'm looking at this going, that just looks like a straight line. And if it was the super simple straight line, it'd be y equals like x plus 6. Okay, well, it's kind of that, almost that simple. But where would it have gone through if I had continued it down there? What would its y-intercept have been? Again, wish I was doing this on graph paper. It would actually hit here. It would hit at 0, negative, or at 0, negative 1. And so then my y-intercept should be negative 1. Unless, are you sure they might graph it on graph paper? I'm pretty sure it's minus 1. Does that make sense to you? No? Are you doing it on graph paper? And would it touch at negative 2 or negative 1? Would it? Okay. I will believe you. Does it have a slope of 2? If every time I go up 1, does it go up 2? Yes, it does. It does have a slope of 2. Very good. Good catch. You were right. I was just not trusting my graph because it's not on graph paper. Okay, so then if it would have touched down there, then this would be negative 2. And then what's its slope to? There. There's my equation. That's rectangular, isn't it? Oh, wait. That would be the rectangular equation that goes forever in both directions. So we have to stop it. Where? We have to stop it here and here. So that's called a domain. And that's going to say, but x has to stay between these two things. X has to be between 1. Remember, that's the spot where x equals 1. And what is x at that spot? 3. Notice it's right here. From 1 to 3. There. If the graph's easy enough, you can just look at it and say, okay, what's its slope, what's its y-intercept, and then what's its domain? Its domain is the x values. At this little exact spot, it was at 1, 0, and at this exact spot right here, it was at 3, 4. So it goes from 1 to 3. That's the x values. Okay. Now, for those of you that can handle it in a more generalized approach, instead of just like looking at it and knowing what the graph is, thank you. If you're going to try this the hard way, you have to be able to do it where you solve for t on both equations. It's really not that hard. If I want to solve this one for t, I'm just going to subtract 1 from both sides, and I have x minus 1 is equal to t. And then I'm going to divide both sides by 2 on this one, and I'm going to say t is equal to y over 2. Do you get I solved both of them for t? They both have t equals. Now I can set them equal to each other. Do you remember those deals where we're trying to get polar changed into rectangular? And anytime it was an r or a theta, you had to get it switched over so there was only x's and y's? It's like that. This has x's and t's and y's, and I want it to only have x's and y's. So I solve them both for t, and then I set x minus 1 is equal to y over 2. And guess what happens? When I multiply that out, it'll be 2x minus 2, which is exactly what I wanted. And where do you get your domain from? The chart. X can go from 1 to 3. Yes? Yes. If it said from 0 to 5, then t has to go from 0 to 5. You figure out the 0 and the 5 spot, and then you find the x's of that. It's always the x's that are your domain when you're done with rectangular. All right, let's see if you caught all of that. New equation, x equals 6x minus 4. Y is equal to x plus 1. And what's wrong with it already? They have x's in it. What are they supposed to have in it? T's. 6t minus 4. And what did I say before? T what? Just so you don't have to rewrite it, or I can make up anything. Okay, fine, I'll make something up. T plus 1. There, that's a parametric. Wait, need something else, or it won't really be a parametric. Domain. Domain has to be, t has to be between something and something. We're 9 times out of 10 just going to say 0 to 2. Why not 0 to 1? Because then you only have 2 points. And then what if the thing's a curve? Do you get it's really hard to tell what the curve is if you only have 2 points on it? You want to have multiple points. So I'm going to usually say between 0 and 2. What I'd like you to do is make a TXY chart, sketch it quick, and then change it over, focusing on the changing over because that's the new thing that you haven't done before. Change it over from parametric into rectangular. This is complicated enough. I gave you a partner. That's why you got the partner, so use them. Pause for a second while you try to complete this thing. Okay. 0, 1, 2. I'm going to put in 0. At first, it's really easy because I only have 2 things to look at. So x is negative 4, and y is 1. Raise your hand if you had negative 4, comma 1. Okay, awesome. Would you give me the other 2? Could you give me the next 2? 1 goes in and you get 2 and 2, and then 2 goes in and you get 8 and 3. Can you guys verify are those correct? Okay, awesome. Then if I graph them, remember which ones you graph. You only graph these. And therefore, we are at negative 4, comma 1 is a dot about there. 2, comma 2 is about there. And 8, comma 3 is a dot about there. Did they appear to be in a straight line? They should, because there's no squareds in this. If there was squareds in my what do you call it, parametrics, then you would have had a curve. I draw a line through them. That is correct. Do I put arrows on the ends? No. Do I put arrows in the middle? Yes, and I show which way they go. And I also should label this. Who gets the bonus for saying t equals 1? Oh, I can't write my t's anymore. I'm t disabled. T equals 0. T equals 1. T equals 2. There we go. Who had the t's in there? Okay, awesome. So, and an arrow. There. Whew! Finally done. And now I get full credit on my test. Yes. Now, do you remember the other part? This is be a different type of question. Change this set of parametric equations into a linear equation. And some of you could look at this and say, okay, I can do this without even doing that fancy other thing. I can see this is a y equals some slope. How much rise and how much run? Well, it looks like it's going, if x is going up like 6, y is going up 1. And so rise is 1, so 1/6 x, and then it's a little trickier to figure out what that is. That's kind of a pain. So doing it this way is not very fun. So do you remember the other way? Did you solve both equations for t? Do you know what I'm talking about? You're supposed to take both equations and solve them for t. If you've already done this, please raise your hand. I need to know who's already done that part. Okay, good. Then I'm going to do that. I always look to add or subtract first. Adding 4, and I would get x plus 4 equals 6t, and then I'm going to divide by 6. Did you get x plus 4 over 6? Okay, and then I'm going to put that with the other one. I'm going to make some room here. I guess I'll just put it down here. X plus 4 over 6, and that's one of my t's. And the other t, we'll go over here, is that one's a lot simpler. And here I just set the minus 1, and t is equal to y minus 1. Do you get I just have to multiply both sides by 6, and I'll have y alone? Wait, I won't. Not quite yet. Sorry. Actually, I could even just subtract or add 1 to both sides and be done. But I'd have that annoying little denominator. Let me show you what I mean. I could plus 1 and plus 1, and I'd have x plus 4 over 6 plus 1 is equal to y. And that would be okay. But it'd be a lot nicer if I could put these together. Would you agree this is 6 over 6? Common denominator. X plus 10 over 6. 1/6 x plus 10/6. There it is. How many of you got that or something that's equal to that except a little different form? Okay, good. And who remembered to do the domain? 4 groups. It's easy to forget that, isn't it? The domain on this matters because otherwise you're giving me a line that goes forever in both directions, and this doesn't. What does it go from? You go back up here, you find it here to here. Remember, it's an x domain. -4 to 8. I like doing that this way. Bracket, sorry. And I like doing that this way. I'm okay with either of those. But if you don't have a domain, you're going to lose a lot of points. In fact, that would be a big enough mistake to lose the whole credit for the problem. You got to have a domain. The domains are a big deal in this. Okay, you've learned everything. Awesome. Let's put it all together in a homework question. You have only 4 problems, and I'm doing one of them. That'll leave you with 3 to walk out of here with for homework for tonight. And some of you have been slacking. I'm going to start doing something slightly different on homework. I'm going to have you Dropbox your homework each night. And I will grade whichever ones I want to grade. Okay, I got to give you incentive to actually keep doing your homework. It's the spring. You're sick of doing everything, and you get to be done soon. In about a month, you're done. You're out of here. We are 8/9 of the way done with this year. You're 8/9 done. You have 1/9 of the school year left. But I'm going to have you Dropbox your homework. All right, so keep doing your homework, please. It's only 3 questions. It's doable. It really is. I mean, it's 4 questions, but I'm doing one with you. Okay, so everybody find your homework. I'm going to pause while we do that. Okay, here it is. It's this yellow page. Okay, and then I've even got it started here for you. What did I start with? A TXY chart. You should do that. And I put in t equals 0 and t equals 1 because it's okay. Some would argue you should have more points than that. I would argue no, because of what shape it makes. Do you get if it's a straight line, it doesn't really matter how many points you have? If you have 2 dots, you get the beginning and you got the end, it's a straight line. There's going to be other dots, they'd be on that line, so I think 2 points is good enough. But notice I labeled them with my t equals 0, my t equals 1, and I have an arrow on it. You want to try to remember all those things for the test. Because to really be doing a parametric right, you got to understand there's direction And you got to understand where it starts and where it ends. Okay. Now, let's do the convert to non-parametric part. See this part right here? All right. I'm going to do that on a separate page. If I were you, I'd insert a page into my document because I don't know where in the heck you'd have room to do all of this. So I got to solve both of the equations for t, and then I'm going to have to get my domain right. Ooh, my domain's easy. Do you see it already? I see the domain. Look on the TXY chart. Do you see the domain? It goes from -3 to 1. There, that part's easy. My domain's done already. Now I just got to figure out my XY equation. Why not these? They have t's in them. So I'm going to solve x equals 4t minus 3. And then what was the other one? Y equals what again? Help me. 6 something? Thank you. And then I'm going to go plus 3, x plus 3 equals 4t. Can you leave it like this? Absolutely. You can totally leave it like x plus 3 over 4. It's just going to get messier if you make it into fractions. Then we're going to set that equal to the other one. Always look to add or subtract first. Can I add or subtract something to make this better? Yeah, you could add what? Add 2. Now you look to multiply or divide. Can I do something? Divide by what? There, t's alone. I know you're used to solving for y. You know, 9 times out of 10 you solve for y, but it already was solved for y. We're going to have to solve for the other thing. Okay, so now I've got these two things. X plus 3 over 4 and y plus 2 over 6. And I got to set those equal to each other. So I'm just going to do that right here. Equals x plus 3 over 4. And then you could times by 6 on both sides. And notice the t's are gone. It's just about solving for y now. You could multiply by 6 on both sides and then multiply everything by 4. Another kid would say, I'm just going to multiply everything by 24. That's fine. That would cancel stuff. Another even smarter kid would multiply by something smaller, but get rid of both of them at the same time. I know it's not a bad system to go multiply everything by 6, then multiply everything by 4, but it's clunkier than multiplying everything by 12. Very good, because do you get how timesing by 12 here will allow the 6 to cancel with the 12? And multiplying by 12 here will also allow the 4 and the 12 to cancel. See what I mean? That can cancel with that, and that can cancel with that. Because if you can factor it, you should, right? So I'm going to redo this 12 as 6 times 2. 6's will cancel. Redoing this 12 as 4 times 3, and the 4's will cancel. Final answer, 3 times the x plus 3 is equal to y plus 2 times 2. Don't forget, there's parentheses. By now you should know when you have a big fraction, you should just slap parentheses around anything that isn't a single term. If you got 2 terms, you should slap parentheses on them so that you don't by accident miss this distribution. One of the top dumb mistakes in my class, forgetting to distribute. All right, so then this ends up being 2y plus 4. And what am I solving for again? It helps when you got multiple variables to keep asking yourself, what am I solving for? Solve for y. Ooh, took a lot of work, but there it is. Don't forget the domain. What did I say it was again? It's off the TXY chart. I'll go back a notch. Oh wait, it was on a different page completely. If you look on the TXY chart, you'll see what the x's were between. Let me go over there on my PDF. There it is, between -3 and 1. That's a problem for beginning to end. You have 3 like that. That took me about 5 minutes. That means for you, probably 20 minutes of homework. And you have a key, though. Yes? Do you think there's a mistake? I believe that there could be. Where do you think the mistake was? Oh boy, where in the heck are you to get the...
3 times 3 is 9. 9 minus 4 is...
Oh, I forgot to distribute. Oh, top dumb mistake in my class, and I did it myself. You are right. Sorry about that. There's a 9 right there. Oh, I see why you kids do it too.
It's not a 9. It's 9 minus 4. Plus 5.
Didn't I put the... I don't understand. Didn't I miss this? 3 times 3 makes it 9?
But then you subtract 4.
Oh, because it was up here. I should start up here with that and then subtract the 4. Okay, you're right. So, tried to fix it real quick. Can't just fix it that quick. That was a 3. Have I replicated it properly? And this does sum up one of my also things that I say a lot, but I sometimes don't do. You should show your work. I tried to do step in my head. Boom! One stupid do step in my head, and if I'd have just actually multiplied it all out, I probably wouldn't have done that. So I shouldn't have tried to do it too fast. All right. Thank you. I'll finish it for the people that like complete good notes. And cancel. I would be fine with this because it is solved for y. And some people will say, but I want to do it like this, Mr. Server. Either one of those would be an okay answer. Okay. Whew. And then the domain, which I already wrote down but erased, so I'll put it back in. Needs to be from to, I think it was -3 to what was it again? Thank you. Okay. All it took is forgetting to distribute. World crashed. Oh, you're okay. You're doing on that same page that we just did the first problem on. You're going to do this one, which is pretty much the same. And it's like for a beginner, that's where you should be. Okay, but for honors pre-calc level, we definitely would go up a notch. So on the next page, we're crossing off this one. It's at least got a squared in it. So that's got a curve to it. Okay. So that's just a little bit harder. Once you actually get good at these, an R3 level type question will be that guy. Because it's really not that scary. Just make a TXY chart. And I suggested kids use -90. Do you agree that's the same as -pi/2? Please don't shut your iPad when I'm still explaining things. And I told the kids they had to give me these 5. 1, 2, 3, 4, 5 angles. Why so many points? Because it's a curve. Do you get if you only have 3 points? You can't really tell, like, tell me exactly how that curve looks. I can't tell. Is it like this? There's a lot of different curves that could go through 3 points. But if you make 5 points, you'll be pretty much dialed in. All right. Question? So I did -90, -45, 0, 45, and 90. And then, do you remember how to do cosine of 90, for example? In case you've forgotten, cosine of 90, you draw a little picture for it, and you can't draw a triangle. Cosine of 90. Oh, actually, let's start with the -90, because I already have the picture for it. You can agree that that's where -90 is? Do you remember how to find cosine of a spot like that? Cosine's the x. Sine is the y. And so this spot is at 0, -1. And so therefore cosine of it is 0. Sine of it is -1. So -90 gives you 0 and -1. The ones you graph again are these two. You don't try to graph your angles. So when you're done, you won't be graphing those. Okay. Now remember, I'm going to be starting to look at each drop box And I can't grade every assignment every night. I don't have time for that. But at least for a while here, I want you to Dropbox every assignment as we do them. And that's all I got for you for today. I don't expect perfection, but you do have an answer key.